You use it every second of every day, but almost nobody understands how it actually works. So let's finally explain the internet properly. By the end of this, you'll understand what really happens in the moment you click a link. And it's genuinely incredible. First, the biggest myth. The internet is not the cloud, floating somewhere magical. It's physical, astonishingly physical. It's millions of miles of cables, including giant ones lying on the ocean floor, connecting entire continents. That's the real internet. Your data doesn't float through the air to the other side of the world. It travels as light through glass fiber at unbelievable speed. Now, every device on the internet has an address called an IP address. Think of it as the postal address for your computer. When you want to reach a website, your computer needs that site's address. But you don't type numbers. You type a name. So how's that work? This is where one of the internet's unsung heroes comes in. A system called DNS, the phone book of the internet. You type a website name, and DNS instantly looks up the actual numeric address behind it, so your request knows where to go. Now your request has an address. But the internet is unimaginably huge. How does your data actually find its way there? Your data is broken into tiny pieces called packets. Each one is labeled with where it's going, like thousands of little envelopes. These packets don't all take the same route. They scatter across the network, each finding its own fastest path, then reassemble at the end. Special machines called routers act as the traffic junctions, reading each packet's label and passing it towards destination, hop by hop. It's a relay race across the planet. Your packet hops from router to router, getting closer each time, often crossing the world in milliseconds. And the rules that make all of this work together are called protocols, the shared language every machine on the internet agrees to speak. The most important is TCP/IP. It makes sure your packets arrive in order and resends any that get lost along the way. Reliable by design. Now let's follow a real click. You type a web address and hit enter. Watch what unfolds in under a second. First, DNS turns the name into an address. Your request is packetized and routed across the world to the right server. That server is just a powerful computer running day and night, storing the website and waiting for requests like yours. It receives your request, gathers the page, breaks it into packets, and sends them racing back to you across the same kind of journey. Your browser catches the packets, reassembles them, and draws the page on your screen. All of that in the blink of an eye. Now, a crucial part you rely on without thinking, security. When you bank or shop online, your data is scrambled so no one can read it. That little padlock in your browser means encryption is on. Your packets are locked, readable only by you and the site. That's HTTPS. Without it, anyone between you and the website could read everything. With it, they see only meaningless scrambled noise. So who runs all this? Nobody and everybody. The internet is a network of networks owned by no single person or government. Your home connects to an internet provider who connects to bigger networks who connect to each other. A web with no center. That's also why it's so resilient. Knock out one path, and the packets simply route around the damage. It was built to survive. So the next time a page loads instantly, picture it. DNS lookups, packets scattering across oceans, routers relaying, servers replying, encryption locking it all. A planet-spanning machine built by humans doing all of that for you faster than you can blink. It's one of our greatest creations. And now you actually understand it, which puts you ahead of almost everyone who uses it every single day without a clue. If this made the invisible finally make sense, subscribe. We explain the world you use but never see. Real tech, zero hype.